Hi, I did an experiment, and that experiment was to test a digital twin that is hosted on a web browser. Uh, so testing the communication of to and from that digital twin to a REST API or a backend application via HTTP and via MQTT to other nodes, other MQTT clients. So these other MQTT clients may represent a dashboard or a physical device. Yeah, so I have this kind of setup. The backend application is a Laravel application. The physical device, I'll be using a Node-RED instance. I've configured something using Node-RED dashboard. Then I'll have a dashboard that will be represented by MQTT Explorer, and yeah. And then on the digital twin itself, there is a front-end application based on Vue, and within the same application there is now the digital twin itself, which is the virtual environment built in Unity. So it's a UnityWebGL application. Now, when I say digital twin, I am referring to the kind of digital twin that deals with real-time simulation of 3D elements of a machine or an asset. And so this is like the entry point of the application. So think of it, maybe there's a company and you want a virtual environment that people can use to work with their machines, but this is your main website and you want to have it communicate with the other one, so with the one that hosts the digital twin. If it's another website, it doesn't have to be another website, but for this case I just have it as another website. So here you have some details that gives you a bit more insight to how the whole thing is set up. You have a user credentials, so this is the information that will be needed from the backend application. So the front-end okay, I'll talk about the front-end application a bit later, but the front-end application requires authentication from this backend, so the REST API. And authentication is based, these are some of the users that are available for testing, and then there are some MQTT topics, MQTT credentials, and now some small information about the digital twin itself. So the digital twin is actually just a lab. It's a room that has two machines, and those two machines, we should be able to the two machines in the lab, we should be able to see some interaction somewhere. So I'll launch the DTLab, and at the beginning this is what I get. So it's a simple website. It's located on a different subdomain, DTLab.Tha-Intersect online. You can decide. I could probably host this, or there's parts of this that I could probably host on this page or on the same domain, but I didn't want to do that. I wanted to be a bit more adventurous, and so I just have it on another website or another subdomain. So let me try login to this with these credentials. So I'll take the first one, for instance. Password is digital twin, and sign in. If a successful sign-in was possible, you get this screen, and then you can see at the top here we have the name of the current user. So the name of the current user is displayed here, so that means we had a successful authentication. So let me drag this other window here. So there you go. So these are still details of the same client, the same broker, a client that connects to the same broker, only that this one is based on TCP because it is MQTT Explorer, and this one will be based off of WebSockets. So as soon as I connect, and by the way, this SSL encryption is actually the same as this option right here. So, and it's actually a checkbox, so you can toggle it. So beware of that. So if everything is okay, so this will be loaded in by default, but if you have your own broker that you want to work with, you can still connect it, you can still use it. When I connected broker, we see, so this is the first piece of information. The first topic is new client connected from blah 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 from East Africa. That is the first message we get from the client or from the front end application. So like the first thing that I'm being prompted to do is enter a preset time for the microwave oven. So, and it's in seconds, so input oven time, that's what's written there. And I could put let's say 60. 60, okay. And there's our application. So this is the environment. It's quite simple. There's really nothing fancy. Let us note that at the bottom left we have DT user A. We have the username. So you could see that information has come from the backend server. So think of it as from the REST API. This can be like that websites, the website of the organization or something. So that information comes from there. So if I use WASD to move around, I'll set the time. Now we added 60 seconds, but that should have been displayed here, but it's not. But if I click on 5, if I press on 5, so hover the cursor over at 5, and the top left it's written LMB at 5 minutes. So when I should click it, right now you see it's saying 6, so it's taking the 5 minutes, which is 5 minutes is 5 times 60, 300 seconds, and it's adding it to credit, and it's adding it to not credit, the initial time that we put, which is 60 seconds. So when we start the microwave oven, okay, so the oven starts running, and let's look at the MQTT Explorer. So notice one thing: we have two topics that have been, we have some information published to two topics on our MQTT Explorer. So this is supposed to be our dashboard. We have UV state and UWave state, sorry, and target time. So target time, it was 360 seconds, which was 6 minutes, and we have UWave state, which was which says that the process is done, so the microwave oven is running. Now right now I'm not sure, something is not quite right, because I expected the microwave oven to, so I expected some information to be published, and I could see that it wasn't published. So let me try something again. I'll add 2 minutes, and then I'll start again, and then I'll stop. So I started and stopped, and notice we have some new information. So when I stopped, we have UWave state is now 0, so that shows that the microwave oven has stopped. And remember we said target time, we said 2 minutes, so it's now saying 120. That is the target time, but there's also the remaining time, which is saying 114 seconds. When we look at this, 114 seconds is really just 1 minute and 54 seconds. So that kind of shows how information can actually get from the digital twin running on the web browser to a dashboard somewhere else via MQTT, an IoT protocol. I want to try control this fan right now. And by the way, the models here they don't look as pretty as they originally look. You could click on this credits button, and you will see you'll see the original works from these designers. So thanks to them, I was able to put this all together. Anyway, let me proceed. So I want to go to it now. Let's say this, what I'm going to show you is, say a real live, no, not a real live, but a simulated sensor in the field. So this simulated sensor gives us the information about the what is it called, the fan speed. So I have set up something simple using Node-RED and Node-RED dashboard, and this is it. And let me now drag the fan, drag this. So you can see at the bottom right here we have we have some information on the current speed of the fan. move the slider, you could see that the fan speed is actually changing, and this is from a different yes, it's within from the same domain, but it's pretty much doing its own. I mean, this is supposed to simulate a sensor from the field, and it's communicating to the digital twin on the web browser via MQTT. And sure enough, when I look at the dashboard, you could see the current speed of the fan is 751. I could still now, MQTT Explorer is running on my local PC. So if let me try publish something to it. If I publish say 0, wait, come on, 0 0. If I do publish 0 to the same topic, there you go. So it has published it, and you can see it's the fan speed. The fan has stopped, and it's actually the speed is 0. So if I start it again, so the default start speed is 500, so that's why it's jumped up to 500, and stop is 0. Now I did not put when I start the fan, that information is not published, so you can see it's still at 0. So I just left that out, but it's still possible to have that working. So anyway, so with that, you could clearly see that we've been able to, number one, we've been able to have the REST API communicate with our front-end application, which is pretty normal. That is normal. That is quite easy. But more than that, we've seen that information from this REST API has been able to reach our digital twin, and that was demonstrated through the user. The name of the user displayed down here. Number two, we were able to, of course, there was communication between the two because of the authentication process. The front-end application submits the usernames and passwords and then back, so that shows that. Then between the two, there was also some communication between the front-end application, which was developed in Vue, which is based on Vue, and the digital twin based on UnityWebGL. We noticed that we had the 60 seconds, the input preset time that we were prompted at the beginning. So that shows communication from the front-end application to Vue. From the Vue app to the digital twin. And likewise, we were able to get information from outside of Unity, from the digital twin to the outside world, and that we could see that through the values from this the dashboard, quote unquote. We could see the target set, the UF state, and the remaining time. All of that was published from the Unity digital twin. So that means that the information had to go all the way to the Vue application, then to the broker. And lastly, we saw that we could actually get data from the physical device, which is a simulated we simulated a sensor that gives the speed of a fan, and that data came all the way from Node-RED to a broker, to our front-end Vue application, and to our digital twin. So with that, I think my experiment was successful. I mean, I have positive results. I was curious on whether this could work, and it actually works. So yeah, if you made it this far, thank you for listening. So you could access all this through, right now it's available at main.tha-intersect.online and dlab.tha-intersect.online. I don't know for how long I'll have it hosted, but I may bring it down sometime later, and I'll try I'll actually put the project on my GitHub so that anyone can host it themselves or do whatever they want to do with it. Also remember that if you want to get some information on how to some credentials, this will be it. For the time that this is live, the credentials can be found at main.tha-intersect.online for the user credentials and the MQTT credentials. So with that, thank you, bye.